So as we look at our notes from today, what we're going to do is we are going to graph the quadratic function from standard form using all the data that we used yesterday or on Friday and what you are working through just now. So let's walk through the steps real quick, what we're going to do. Step number one, first in our heads we identify what A, B, and C are. Next, you find the axis of symmetry, but we're going to sketch it rather than just find it. Next, we're going to find the vertex, and we're going to plot that. Last, so then we're going to plot a y-intercept or some other point. Y-intercept is the easiest, and a reflection, and then all we have to do is sketch. So it's actually fairly fast as we walk through this. Good, so the value of A is +1, the value of B is +2, and the value of C is -5. Remember, every time we are looking for the axis of symmetry, please start by writing x equals -b over 2a. And then when we substitute in, we are building in the memorization of that. So I bring down the negative, the 2 gets substituted in, a 2 is down, and the 1 for a goes there. Now we simplify to get -1. So I'm going to find the axis of symmetry. Yay, just did that. Now I'm going to sketch it over here. Now before I even do that, I'm going to take a quick sketch right here and just show you that the axis of symmetry is going to be somewhere like there. And why am I doing that? Because I want to know real quick which of these quadrants I'm going to be using before I commit to everything. So, for example, I might end up graphing something that looks like this. Like if you graph this, but then your vertex was here and it graphed like that, you'd be way off graph or way off the coordinate plane. So that's why I'm just going to do a quick sketch before I commit. All right, I know that it opens which direction. There we go. So because of this positive right there, we know that the vertex opens upward. And now, excuse me, not the vertex, the whole parabola opens upward. And now to find the vertex, I'm going to substitute in the -1 in that we got from the previous, from step number 2. So I take the -1 and square it. Then I'm going to say 2 times -1 and bring down the -5. Continuing on, double negative is positive, -2 -5, and our end result here is -6. So my vertex is -1, -6. So if I were to sketch this real quick, -1, -6 is somewhere down here, and I do know that it's going to open upward like that. So when I make my graph over here, I'm going to focus my attention primarily in quadrant number 3. I focused on quadrant 3 here. So now I plot the point, -1, -6, right here. And now notice one other interpretation that we have from over here. Notice that the number that's all by itself, we call that the constant. The constant is also the y-intercept. The constant is the y-intercept. So over here, my axis of symmetry is here, and I know that my y-intercept is right there. So when I reflect that across, now we can go ahead and begin to make the curve fit. So when we were looking here, it asked us to plot the y-intercept, and I said, or another point. Why did I say or another point? Well, sometimes as you're graphing, the vertex could be on the y-intercept, like this. If the vertex is on the y-intercept, then plotting the intercept and the vertex is just plotting one point. So I wouldn't be able to to gauge which direction, nor would I be able to gauge how wide it is. So plotting another point just means, at this point, you can just take another, an x value, so x equals 1 and plug that in, or x equals 2 and plug that in. So it actually doesn't matter if you use the y-intercept or any other point, but y-intercept, there's no calculation. It's just already given to you. So next one here. Go ahead and find the axis of symmetry. Go.